Welcome to lecture 8 of design and analysis of algorithms. Here we are going to discuss about solving recurrences, recursion tree method. So recursion tree method convert equation into a recursion tree. So where each node in the recursion tree represents the cost of a single subproblem. Then we'll add the cost within each level of the tree to obtain a set of par level costs. Finally, we'll sum up all par level costs to determine the total cost. We'll understand with the example. Solve the following recurrence using recursion tree method. Okay? There are several recurrences will be there. So we'll solve those recurrences using recursion tree method. So as I have said earlier, that this recursion tree method, this will convert a recurrence into recursion tree, where each node of the tree will represent the cost of a single subproblem. Okay. So why subproblem? You see, these are uh, following divide and conquer approach. So here every time the input size n is getting reduced by n by 2. Okay. So that's why those are smaller problems we will say subproblem. Okay. Then we will add the cost within each level of the tree to obtain a par level cost. Finally, we will sum up all the par level cost to determine the total cost. So how we are going to do it? You see, so this kind of recurrences will be given. First of all, your task is what? Here you see, instead of writing this theta n, what I can write? I will replace with any constant multiplied with n. So can I write c into n equal to theta n? Yes, because it is asymptotic notation, right? So in asymptotic notation in tight bound, okay, we have seen that in all asymptotic notations in general, we do not care about constants and lower order terms. So if constant is present, we can ignore it. But here you see, let's say, to simplify our uh, solution, so we are going to write c into n, okay, because we do not know which constant was ignored here. So let's say c was the constant, okay. Now you see the problem of size n is reduced or broken down into two sub problems where size of each sub problem is n by 2 and the cost of dividing and combining together is theta n. Okay, so here we are writing cn. So as we have seen here, that each node in the recursion tree, why recursion tree? Because recursion tree method will convert this recurrence into a tree where each node will represent the cost of a single subproblem. Okay, so let's say the top level, at the top level here I'm going to write, so the cost is cn. So here you see the cost is cn when the size of the problem was n. Then this problem of size n was broken down into two subproblems. So here it is 2, that's why 2 branches are there. Okay. Now what will be the cost here? See, now your problem size is what? N by 2. Okay. What is the cost? C n by 2. Here also same, 2 subproblem of same size. Okay. C n by 2. Again if I break it, okay. Now your problem size is what? N by 2. So here in place of n, if you write n by 2, what will happen? So 2t n by 2 by 2 means what? Here the cost will be n by 2 square. Why? Because when the problem size was n, the cost was what? Cn. When the problem size is n by 2, the cost will be what? Cn by 2. So here we have seen n by 2 square. So here also it will be what? Cn by 2 square. Similarly here also Cn by 2 square, Cn by 2 square. So like that it will go. Okay, it will expand. Now where it will stop? It will stop when it will find the base condition. Now what is base condition? When n will be equal to 1, problem size will become 1. Means what? Here we will get T1, right? So T1. How many T1s are there? We do not know now. We need to find it out. Okay, T1. Now you see. Per level cost. What is the cost at this level? Level 0, right? That is Cn. What is the cost at level 1? Cn by 2 plus Cn by 2. Because we will add the cost within each level, right? So that is also Cn. So what is the cost at level 2? So we will add all this cost. So that will be also equal to Cn. Here you see 2 square means 4. So 1 and 2, 3, 4. So that is also Cn. So like that, you see, very important point here. Most people ignore that thing, but you should not ignore it. Here you see. Now, at this level, this is, how to find out this level. First of all, you do one thing. You just compute the height of the tree. So here it will stop at T1 and it starts from this, topmost level, level 0. So what is the height? So height of the tree is what? Here you see. Every time the problem size n is getting reduced by a factor 2. If something is repeatedly divided by a factor, so you can always think about log. Log n, because the problem size was n, it was repeatedly getting divided by a factor 2, so then that will be the, if here 3 is present, then base will be 3. Okay, so you can simply prove that also. Okay, like n, then n by 2, then n by 2 square, like that it will go up to n by 2 to the power k. So that should be equal to 1. Then n by 2 to the power k equal to 1. So then what will be the value of k? K will be equal to log n base 2. Okay, but in simple term, you just understand, if this problem size n is getting reduced every time by a factor 2, then it will be what? That we can write log n base 2. So if you see here it is 2, so here the base is 2. Now the height is from this root node up to here, right? T1. Now what is the cost here? The cost here is also at every level the cost is Cn. So at this level also the cost will be Cn. Yes. Okay. Let's say there it is Cn. Because on level 0, level 1, level 2, level 3, 4, 5, like that it will go. So every time we are getting same cost. So that there also will get the same cost. But what is the cost here? Here will it be Cn? We need to check it. Because here you see, here it stopped. And what is the cost of this T1? T1 means n equal to 1. So when n equal to 1, T1 is equal to 1. So here the cost of each node is 1. But how many nodes are there in the tree at the last level? How many? How many nodes are there? We need to find out. And then we'll multiply with the cost of T1, right? Then we'll get the cost at this level. Now here you see, so at level 0, how many node? 1, right? At level 1, how many nodes? 2, right? At level 2, how many nodes? 4. So how we can express? We are going to find a pattern, right? 2 square. So if it is 2 square, it is 2 to the power 1. So what we can write in place of 1? We can write 2 to the power 0. So here it is 2 to the power 0, right? Here it is 2 to the power 1, 2 square. These are number of nodes. Okay, number of nodes. So I am representing using hash, number of nodes. Okay, so like that it will go. So here what we will write? 2 to the power, how many nodes will be there at this level? Okay, second last. So here it will be the height of the tree log n base 2 minus 1, right? Why minus 1? Because it is not the last level. So here, how many nodes will be there? 2 to the power log n base 2, because that is, up to the height of the tree, into what is the cost of each node, that is t1. What is the value of t1? That is 1. Okay. So cost at this level is what? So we have seen a very important uh, formula in logarithm. We can exchange this to 2 and n we can exchange. Okay. So it will be what? N to the power log 2 base 2. That will be nothing but n. So here at the last level, the cost is n. We will add that separately. But here, let's understand this. So what is the total cost? That will be our answer, right? So we will, here it is said that sum up all the par level cost to determine the total cost. So Tn equal to par level cost is what? Here it is Cn. So in all the levels, it is Cn except the last one. So Cn plus Cn, like that it will go, Cn plus Cn plus dot plus Cn, and then we'll add the cost of the last level. So theta n I am writing. Why? Exactly n we have seen here, so we can write using tight bound. But how many Cn's are there? How many Cn's are there? Okay. So up to this, from here up to this. Okay. So how many Cn's are there? So height of the tree log n base 2 minus 1, right? So if we simplify, okay, what will happen? So here let's say we are going to ignore this 1 because we are going to write asymptotically. So log n base 2. So log n base 2 multiplied by Cn, because log n base 2 number of Cn's are there, right? So Cn multiplied by Cn log n. Since it is log n base 2, we can write LGN simply. Okay. Plus theta n is nothing but n. Okay. Simply you write n. So here, if I express in terms of big O, what I can write? I have to select the highest order term, ignoring all other lower order terms. So here it is n log n, because n log n is having higher growth rate than n. Okay, and c is constant, so we are ignoring it. So what is our solution? The solution for this recurrence using recursion tree method, that is n log n. So this is how we need to find out the solution for the recurrences using recursion tree method. Now the next example here, okay. So here also we will do what? First of all, the top level cost. So that is C n square. Then the problem of size n is broken into 3 sub problems. So three sub problems now. So 3 branches. So here just you can ignore this floor functions, because we are going to provide the solution anyway in asymptotic notation like big O. In upper bound we will provide the solution, so we don't care about this. What we can write? Then is the top level cost. Okay. So the cost here, it will be C n by 4 square C n by 4 square C n by 4 square. Okay. Now again, this will be broken into 3 parts. These are problems. This will be also broken into 3 sub problems. Here, now we need to count the cost here at this node. So what will be the cost? Now your uh, input is not n. So here it is n by 4. So what will be the cost? C n by 4 by 4, right? So C n by 16 square. Here also it will be C n by 16 square, C n by 16 whole square. So similarly here also it will be C n by 16 square, C n by 16 square, like that. So I'm not writing those. So like that it will go. So it will go up to the base condition. Here it is when n equal to 1. So T1. So similarly as we have seen in the earlier case, T1. So here also T1. Okay. So like that T1. Okay. So here per level cost we need to find out. The cost at level 0 is Cn square. Cost at level 1 is what? 3 C n by 4 square. Okay. So here it is what? So if you see here we can write this way, like 3 by 16 C n square, right? 3 by 16. So here if we add, here you see how many nodes? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So 9 C n by 16 whole square. So what we can write to find a pattern? So 3 by 16 whole square Cn square. It is 3 by 16, the height of the tree minus 1 Cn square, right? So what is the height of the tree? So height of the tree will be from that point to here. Okay. So what is the height of the tree? So input size n is getting divided by a factor 4 repeatedly. Okay, until and unless it reaches the base condition. So we know that what we need to do. So log n, because the problem size was n, base will be 4. Okay. So what is the height of the tree? That is log n base 4, but minus 1, because it is the second last level. Okay. Now, what is the cost at the last level? What is the cost at the last level? Before that, we need to find out how many nodes are there at the last level. Okay. So how many nodes are there in the level 0? 1. How many nodes are there in level 1? 3. Level 2, 3 square, like that it is going. So up to here, the height of the tree. So how many nodes are there? Okay. How many T1s are there here? So that is 3 to the power log n base 4. So that is up to the height of the tree, right? Here I will write what? 3 to the power log n base 4. Okay. This number of nodes multiplied by the cost of each node. The cost of each node here it is 1, because it is the base condition here. So that is 1. So if you remember though that we can interchange this 2. So it will be n to the power log 3 base 4. Okay. So this is the cost at the last level. This is the cost at the last level. Okay. Now here at every level the cost is not same. Now what to do? So here in this case we need to find out a pattern. Okay. Means we will add up, we will sum up the cost per level cost. So here we will add this Cn square plus 3 by 16 Cn square plus 3 by 16 whole square Cn square plus 3 by 16 to the power log n base 4 minus 1 Cn square. We'll add all these things to find out the total cost plus the cost at the last level. Okay. How did we find out the cost at the last level? How many nodes are there we need to find out, and then we'll multiply the cost of each node to count the cost at the last level. Now I will add up all these things. Okay. and then we will see how to uh, simplify to get the answer. Okay, so here in this case, so the cost here will be Cn square plus 3 by 16 Cn square plus 3 by 16 square Cn square. Like that, it will go up to 3 by 16 to the power log n base 4 minus 1 plus the cost of the last level. Okay, so cost at the last level, we have seen the cost at the last level, that is n to the power log 3 base 4. Okay, so now here, if we take common, Cn square will be 1 plus 3 by 16 plus 3 by 16 square plus dot plus 3 by 16 log n base 4 minus 1 plus theta n to the power log 3 base 4. Now here you see the last term is log n base 4 minus 1. So it looks a bit complicated. So what we can do? We know this is following a GP series, right? So if I can extend this limit up to infinity, it will be less than, if I write, why I am writing, I'll tell you. 3 by 16 plus 3 by 16 square plus, now I will write plus up to infinity. So I have extended the boundary up to infinity. Okay. So will it simplify? Let's see. So here I will simply write n to the power log 3 base 4. Okay. Here again I will write equal. Why? Because I am going to find the value of this thing. Okay. So this entire thing is less than Cn square into 1 plus 3 by 16 plus 3 by 16 square up to infinity, because here we are extending the boundary up to infinity. Okay. So here we can see that infinite GP series sum, so it is very simple to calculate. So it is Cn square. So here it will be, the formula is a by 1 minus r. A is the first term. So first term is 1 by 1 minus r. R is what here? 3 by 16. 3 by 16 divided by 1, 3 by 16, 3 by 16 square divided by 3 by 16, that is also 3 by 16. So common ratio is 3 by 16. Okay. The plus n to the power log 3 base 4. Okay. So if you simplify, you will get a constant here, right? So what you will get? Here you will get Cn square, then it will be 16, 16 minus 3, that will be 13, okay, plus n to the power log 3 base 4. So if we write the solution in terms of asymptotic notation such as big O, what we will do? Out of this term, we will find out only the highest order term and we will ignore the lower order terms and constant. So C is constant, ignore it. 16 by 13 constant, ignore it. Okay. And out of n square, out of this n square and n to the power log 3 base 4, which one is the greater term? The greater term is n square. So here we can write big of n square. So this is our desired solution. So this is the way how we need to solve using recursion tree method. Means in summary, if I say, if the cost at every level you are getting same, then you just multiply that cost with the height of the tree, you will get the answer. But if you are not getting the same cost at every level, then you need to find a pattern and then go with the GP series, or you see whatever their you can apply, then using those things you will find out the answer. Okay, means always we will search a pattern. Okay,